Hello and welcome to a short session about the end of season review of crop nutrition. This is part of an eXtensionAUS crop nutrition project. Crop production is a perpetual cycle, and what is the end of one season is the start of planning for the next. Experience gained and management applied during a season has direct consequences on the future activities, such as confirming strategic directions and helping refine management tactics. There's a range of areas of review such as weed prevalence, disease level, weed resistance strategies commonly undertaken to guide next season's plans. Nutrient review is less common but can be quite useful. Some of the key methods of assessing nutrient management effectiveness include calculating or evaluating nutrient use efficiency ratios, measuring the nutrient content of the grain, doing a nutrient budget, or reviewing test strips. Some of the information is located in records that are kept across the season. So yields and fertiliser application rates are sometimes key to this, and it takes little extra additional effort or planning to actually produce some of the ratios and budgets that might be interesting to look at the end of the season. Whenever reviewing performance, it must be within a seasonal context, as the management activities and climatic factors do influence the seasonal outcome. In a nutrient context, some of the important features might be planting date. Responsive of some nutrients is very much related to the temperature of the soil and the moisture at the time that it's actually sown. And a typical example that might be phosphorus, where sown early, responses are dampened down, and sown late into colder soils, you can heighten a phosphorus responsiveness. Rainfall, pre-flowering, and post-flowering can affect some of the nutrient results that we get. Significant stress events on the plant, such as frost events and heat events, obviously can affect the ratio between the amount of nutrient taken up into the crop and what is removed in the grain, and therefore will affect nutrient ratios and efficiencies. And any other stress events such as diseases, weeds, anything that either competes with the plant or breaks the ratio, the normal ratio that you might expect between the grain yield and what has been taken up into the plant. Some of the most asked questions about nutrient management in the lead up to a season are: what and how much nutrient is required, and how much will it cost? And the other one that's pretty common at any time of year is: how do I know I'm getting the best value for money spent on crop nutrition products? Given that it's generally 6 to 12 months between when the answer to the first two questions are asked and answered and the production is known, it's only really via the review of nutrient use efficiency at the end of the season that the real answer to question 3, how do I know I'm getting value for money, can be answered. Some economic forecasting can be provided via bioeconomic models that are illustrated in this slide, where we are matching biological response curves and applying economic considerations of crop value and input price to come up with an optimization of what is predicted to be the best outcome. The real story, once again, is only ever revealed when we have actuals and we can compare actuals between paddocks, between farms, in such indices such as nutrient use efficiency, or we have a look at nutrient budgets and look how well we're matching soil supply and demand. So how good is our current nutrient management? In daily life these days, we have numerous devices that provide us with efficiency data to help make decisions, and a common one is just a fuel consumption or efficiency device that's in our cars these days. Very, very common. In agriculture, the possibilities are endless, but the usefulness is still largely to be established to drive production and consumption management. So it's not out of the realms of possibility that in the future, if it was important to measure the amount of grain per kilogram of N at harvest, then that could be done fairly easily right now just through a grain monitor on a harvesting equipment. One of the indices of efficiency that we currently do assess quite commonly and reuse again in many seasons going forward is water use efficiency. Sometimes people use industry averages, but farm records are far more useful in calculating potential yields based on what can be expected from the soil types and the management that's applied on top of it. So given that nutrient use efficiency is closely tied to water use efficiency, availability of water use efficiency data greatly assists in interpreting nutrient use efficiency, as does nutrient use efficiency help understand water use. This is particularly the case for nitrogen, which is a very closely aligned index to water use efficiency. The end of the season review of nutrient use can be either fairly simple or as complex as it needs to be to make good decisions. Having good electronic records of actuals makes the data crunching job a lot easier. The numerous methods of calculating NUE, and the simplest and most useful I find are these ones that are listed here. So partial factor productivity, and partial factor productivity is basically the yield divided by the nutrient input. Just a simple yield and nutrient input. Most people can calculate that off the top of their heads. Agronomic efficiency is useful in trying to understand the value of a change in management, or the value of adding nutrients above what the soil could produce on its own. So in that case, agronomic efficiency takes a little bit more work, and it needs a control strip or one that's different to what is normally done on the farm to assess whether you're better off doing something different. Adding to that, to put an economic dimension on agronomic efficiency, is to multiply that into dollars and find out for every dollar we're inputting in as a nutrient input, how many dollars in crop return are we getting. The last one is more a sustainability index, which is what's called a partial nutrient balance, and this is trying to assess for every kilogram of grain we put in, how many are we exporting back out of the paddock. Obviously it'd be nice to be in a case where we're 1-to-1, where we're putting on what we're taking off, and if we're taking off more than we're putting on, then we're running the soil down. It'd be nice to know about that. Another factor that can be very, very useful in determining what is going on with efficiencies is to have a look at what is happening over time. So again, with good electronic tools, these efficiencies can be tracked over time, and obviously what we'd like to see is within reason, or within reason of a range that is indicating good efficiency, that we are either rising or staying within the efficiency range that we desire to have. The other factor that could be useful to track is the variance around the trend line. Decreasing variance or wobbliness around that line indicates we're making better seasonal decisions, and the effect of seasons or other variables that are causing highs and lows in the yield becoming less means we're making better decisions in general. End of season review is not the perfect tool. It has its pros and cons, but overall can be a useful addition to nutrient management. The cons include it is retrospective. It's not going to help you make a change in season that's going to turn a season around. It is, you've got to wait to the end of the season and see how you've gone. It needs to be tracked over time unless you've got very, very good insight into the effect of a seasonal effect on the efficiency. Then it's what is important is what happens over time rather than just season to season. You've got to have context to interpret it, so know approximately what the highs and lows or what range you want to be working within. And it does require field work other than for the partial factor productivity measure. On the pro side of it, it's simple to calculate and evaluate. It uses actuals, not simulations. It's sensitive to management and measurement of management change, which is a very important factor in these days, that when we're trying to improve things, the economics, the sustainability, and considering all of those indices are, making sure we're going forward in a way that is both economic and sustainable. And the other thing it allows you to do is to benchmark between different paddocks, different farming systems, just to see how it's going from an efficiency point of view. So some of the important ones that I've nominated there: partial factor productivity, just the yield of a paddock divided by the nutrient input from fertiliser. It may seem a bit too simplistic, and most people would say, well, what about the stuff that's coming from the background of the soil? How does that factor into this? Well, to stay within the target range of efficiency, you need to be, where seasons change and nitrogen supply changes in the background, your fertiliser rates need to be sensitive to that and adjusted for that, otherwise your efficiencies will be all over the place. So I would contend that this is not a bad index to see how someone is adjusting their fertiliser rates based on background nitrogen supply. Just a quick look at benchmarking paddocks and farms and districts are useful productivity signals, but also on an international level, having some idea of efficiency also gives us some signals about international competitiveness. Poor efficiency with a major gross margin input, such as fertiliser, can indicate decreased competitiveness in the longer term. Some of the other indices that are important, as was discussed earlier, is the agronomic efficiency, because it targets directly the effectiveness of changing a nutrient management, whether that be rate, timing, application method, or rate. Agronomic efficiency measurement can then also be expressed in a dollar term to look at the return on investment of the fertiliser in a situation where we've changed some sort of management. And just to give you an example of that, this table shows recent seasons agronomic efficiencies of 5 to 12 kilograms of grain has been in the range of break even. Through to a reasonable return. So with urea prices around the $690 a tonne, or $1.50 a kilogram of nitrogen in the soil, and a return ratio of 1 to 1, shows that 5 to 6 kilograms is the return when the wheat price is around the $300 to $250. So 1 to 1's break even. If you're less than there, you're losing money. And that can be turned around and saying if you're putting 50 kilograms of N on, you should be seeing around 1/4 of a tonne yield increase just to break even. On the other end, probably making reasonable money at a 2 to 1 return. So if you're putting on 50 kilograms of N and seeing at least a half a tonne to 600 kilos of yield increase, that's been a good season for nitrogen management, because it's been good money in doing that. Partial nutrient balance. We're looking at this as a sustainability index, so an efficiency of 1 is where we've got things in balance. Greater than 1 can mean we're actually running the resource down, or it can mean we've got a nutrient source there that's not being accounted for. So it's not unusual where there's a high frequency of legume nitrogen in a cereal cropping system to have an efficiency greater than 1. Whereas if the efficiency is below 0.7, then we're probably overdoing it with nitrogen fertiliser if that's a consistent trend over a long period of time. And of course, grain protein is an index of water and nitrogen efficiency together. There's been a reasonable number of research trials in Eastern Australia in particular that have shown that once we get up over about 12 to 13% protein, that the residual soil nitrogen left at the end of the season rises quite rapidly as a result of a lack of water at the end of season to be able to consume that. And by the same token, the wheat indicator down here shows that water use optimization is around that 11.5%. So that's why we target around that sort of range of protein in Eastern Australia for our nitrogen equations, is to indicate we've optimized in water and nitrogen. The next area after we move on from nutrient use efficiency is to look at the possibility of analysing grain, so harvested grain, as an index of what nutrients been available across the season. And it's got multiple ways we can do that. We can use the data that comes from the laboratory analysis, and it's just a plain tissue analysis of grain as an assessment of the adequacy of the grain concentration. So for some nutrients, just like we use leaves and whole tops, we can use grain to assess whether the nutrients have been adequate across the season. We can also use the output of the laboratory analysis as a calculation of crop removal and a partial nutrient budget. So the concentration in there is part of the equation that we use to actually understand what's been removed in the grain. The last area is to look at the suitability for seed. A couple of the nutrients in the seed are very important for vigour and viability of the seed, and we can measure that to make sure that if that seed is retained for planting seed, that we have a good seed source for the following year. So the nutrient analysis of grain, this table indicates what I've called trigger values. These are the numbers below which would suggest there may have been some sort of nutrient problem in the crop. As I was explaining before, the reliability of all of these is not great, but in particular nitrogen, sulfur, zinc are quite reasonable, as is the N/S ratio. And for some crops like lupins, manganese can be very useful. Others, such as potassium, really aren't all that useful. We've got a trigger level there, but that's not necessarily highly reliable. In a partial nutrient budget, one of the things that we need to do is to understand what the concentration in the grain is, so we can multiply it by the yield and understand what the removal is. In the past, a lot of nutrient budgets have been done on the basis of a table of removal values that's come from a textbook from somewhere, and that's been a single value. What we now understand is for any region that's probably a range, and there's quite significant variability around that range, and in fact, as the grain P concentration there in that image describes, that can be up to 300%. So how do we get to the right number? Once again, a lab analysis will give you the concentration in the grain for a particular paddock for a year, if we retain some grain for analysis, and then just multiplying the percent value by 10 gives us a yield, a removal in kilograms per tonne. And if we multiply that by the crop yield, we end up with the total removal per hectare in that year. Once again, keeping good records can be useful because we can add the inputs and outputs over time and just see where we're getting to with some nutrients. In some cases, we've got nutrients that we're not currently applying and are at reasonably adequate levels, and over time, if we're not putting them on, they're going to run out at some stage. So keeping an ongoing seasonal budget of what's gone off in a paddock, and what's been applied and what the net position might be, may give some hints as to where and when in the future and where on the farm you might be at risk at running into nutrient exhaustion on some paddocks of some nutrients. Planting seed, in particular P and zinc, are probably the two most common nutrients that are associated with seedling vigour, and the grain can be analysed for the content of those if you're keeping grain to make sure the following season that the planting seed has the best vigour that's possible. Combining information sources is increasingly easy to do because of electronic recording of things like soil testing and nutrient balance information in databases or in software that can put them together, and we can produce these sorts of graphs. And what these are about is combining nutrient sources. We can then end up with predictive or prognostic tools about the time we might get in a build-up phase of a nutrient to the maintenance phase. So how long have I got to put this on, and where's the soil test telling me I'm going to intersect with the critical level where I can put a rate on that just maintains the soil rather than putting on more than the crop is removing. The same token, it can be just as powerful in trying to predict where I've got a net negative and I'm not putting on any nutrient, just at what time in the future that my soil might run down to the level where it becomes responsive. It's nice to know that and be able to plan that into the future production costs at some time in the future. Lastly, as part of the nutrient review that you might consider is if there's been test strips either put down as a planned exercise or inadvertently happening as a result of running out of a product or a blockage or something like that. They are probably the most important information on the farm. And as far as the agronomic efficiency, a nil strip is very important in understanding what value the extra nitrogen might be, or the extra phosphorus that you put on might be above what the soil could produce by itself. The other way of looking at it is to put in a nutrient-rich strip, which gives you some increase idea of the marginal benefiting of an increased rate, but it can also be used to judge seasonally whether a top dress or a top-up sort of in-crop might be a useful thing to do. Both of these can be run for a combination of product placement, timing, or rates to get a better understanding of what are the best options for your farm. Traditionally, this has been something that's taken a bit of effort because we've had to get out and change rates of and cogs on machinery and have yield buggies in the paddock at harvest. Precision ag tools probably bring this a lot closer to being able to be done on the run, particularly where you've got product and rate controllers linked to GPS on the application equipment and yield monitoring and GPS on the harvest equipment. With the right tools, the strips can actually be laid down on the run or put into the application equipment based on some sort of zoning that might have been done across this as a result of the previous season, a bit of soil testing, and automatically laid out the trial on the run. So we end up with a coverage map of all the strips we've put in there, and then across the season you might take a satellite image and use the coverage map to look at how the biomass is developing in those strips and assess the biomass in those areas. It might assess the yield at the end of the season just by harvesting the paddock and then separating out each of the little trial areas from electronically via the yield map. And then we can start to look at relationships that might have occurred and response curves and all of those sorts of things that are going to tell us from those strips what is the best thing and how that nutrient or management has responded in that paddock. So in summary, those areas that we're talking about in reviewing are nutrient use efficiency, nutrient concentration or nutrient quantity in the grain, and test strips. Put together, if we've got all of those going on the farm, we're going to do a lot better job of planning next season based on the knowledge we've got of what happened the previous season. So the end of a season review is a vital learning tool, just as it is with disease resistance, pest planning, all of those sort of things that we put into the pre-season plan for pest and weed and control. So the place to start planning the next crop is the end of the previous crop. Many important pieces of information and data are already collected for other reasons and are just waiting to be joined with nutrient management in a nutrient management context. And improved NUE generally is targeted at profitability